can you hear me? Yeah. We've just seen the presentation from Fabian, who has demonstrated us how we can lower the barriers for data sharing using legislation. I'm going to talk a little bit about the ways how we can lower the barriers for data sharing using terminologies and semantics. I think actually currently we're living in very interesting times, and I really see a tremendous change in the industry, which I have named that we have a fully happening dissolution of boundaries. And I just take Roche, our company, I belong to as an example. And Roche, I belong to the research organization. And as a new experience that we make is that there's more and more need for doing data integration, data sharing across the entire organization. We also have two sister research organizations, Genentech and Chugai, where we intensify the data exchange. But to the same point, which is very interesting, is that we also start to collaborate and exchange data with our marketing colleagues, with the people from development and technical operations. And last but not least, we also have a very strong diagnostics division in our organization. More recently, it's also an interesting pattern, is that when Roche went into acquisitions, we were more acquiring companies that work in the data business than companies that work in the real pharma business. Like Foundation Medicine, which is a Boston-based company having a lot of data about cancer patients, and Flatiron, where Roche has a seed investment, collects real-world data from cancer patients across large clinical consortia in the US. But this is not where the picture stops. I think, as you've also seen, we are less and less reluctant to share data with our competitors. So we put all our data in public repositories like Geo or many others, or ArrayExpress. And we also collaborate on topics like data standards, advanced approaches to data sharing. Healthcare is a very interesting provider of data, and I think they are really more advanced with regards to integrating data standards and technologies than we are. So I've seen very good presentations from Kaiser Permanente, also the Montefiore Clinic, that really have in-depth integration of terminologies into the processes, and they're also able to show that they can really generate value with this data. And of course, this is data which are interesting also for our research in terms of translational aspects. Interestingly, even if you leave our industry, life science, other industries work on the same topics in terms of data sharing, data integration, technical approaches, also based on larger semantics. So we change the business objects, but we are using the same approaches and same methodologies. Then I think a strong part, which is quite interesting, is that we acquire a lot of data from commercial content providers like Springer, Elsevier, Sideline, or Clarivate Analytics, formerly Thomson Reuters Life Science. And we also need to bring this data into our knowledge-driven processes. There is a lot of public data around, we have learned a lot about this, that we can bring into our processes. I've mentioned here, for example, ArrayExpress, Geo. I think there are more than 1,800 publicly available biomedical databases that we can access. And last but not least, we have also the tendency to work more and more with CROs, which creates another data flow, data integration issue. And more in the area of manufacturing, there are also approaches in supply chain management to link systems. And I think the key that now the data has to flow in all directions, has to be shared and integrated in all variations of aspects, is that we need data standards to enable these processes. And so far, I think the main drivers in the industry really to work on these standards and to integrate them have been imposed. For example, we have CDIST, which is kind of a mandatory part for FDA submissions. And more recently, also in Europe, IDMP has set up some standards. So actually, our way to think about data integration, data sharing, has been more driven from the outside and less by inside. I think this is something which is really going to change currently. And I think one of the drivers, which is really interesting, is that there are new players around that somehow try to start to worry our upper management. So there are a lot of AI companies around, and the big players like Google or IBM also work in this area. And I think it was about 10 weeks ago, for example, a UK-based AI company acquired 3 molecules from Johnson. So this is really a turnaround of the relationship. So we always assume that all these companies will work for pharma, but it also seems that it can go the other way around. So the threshold to enter into our business has really gone down. And this really has changed the perception of what we are doing. So another issue that we see in our industry is about data quality and data assets. I think so far, most of the people working in our industry don't consider data as an asset that we need to foster. And if we again benchmark ourselves against other industries, I would clearly say that the pharma industry is a little bit behind, or a little bit further behind compared to automotive, insurance, banking, wholesale, retailer. Just mentioned that next month we will participate in a conference in the US about data governance and information quality. And the only industry which is more or less systematically absent from these conferences is the pharma industry. All other industries have a long track there. And then I think we have this paradigm shift from lab to knowledge. So we understand that our business is more and more data driven. And again, if you compare to Google, who have the algorithms, who have the computational power and the data, this creates a strong drive to really go into this paradigm shift. Last but not least, the change, as I mentioned before, only happens when we are forced, and I think it's now more and more driven by insight that we have to integrate and share data across the organizations, but also, of course, with external collaborations. And very strikingly, and I could talk for hours about this topic, is that whenever we have to bring in knowledge into our processes, there is an incredible variety of the data. So whenever we would like to integrate data, there is always a data integration project and a data curation project. And I think this is when we work on standards, technology alignment, we can avoid a lot of effort and costs. And last but not least, it's also a very interesting theme, is that if we imagine how much money we spend in research and development, other areas to generate knowledge, but when you ask for budget for doing intelligent work with it, for data integration, data curation, or quality assurance, usually the budgets are tight. And this is something which is from a survey not only related to the pharma industry, but if you look into data science. So globally, data scientists spend about 80% of their time on cleaning, organizing, and collecting data assets. They have only 20% of their time for value generation. And vice versa, so if you ask them about what are the biggest hurdles for their work, 2/3 say that the data cleansing and organizing is very important, and also 52% complain about data quality. And I think this is exactly what we address when we try to bring in data standards, control technologies into the processes. At the end of the day, it's about scientific data integration, and we have to reduce the time to value, the effort, and also at the same time we have to improve data quality. So this is again something where I really see a tremendous change in the last 6 to 12 months. It's really going very fast. I think formally, with data standards and controlled technologies, we were kind of niche players. So people said that's nice to have, but it was visible for a very, very small number of people across the pharma industry. And whenever these things got applied, it was only just partial solutions. So isolated solutions where people pulled in some technologies, did some data cleansing exercises, and it stopped there. It's also a little bit about technology. We have learned that, for example, CDIS comes as RDF, machine readable formats that we can integrate. And when we brought up these topics about using semantic technologies, we were always asked, why do you use this technology? And this is something that's also getting less and less important. There was really this strong perception issue. Data quality was and is still strangely neglected. So if you look into our internal systems, and again, I could speak for ages about this, we find so many issues about data quality. And if we go to the business, I think there is a little bit the issue that we have a poor interest to take over the ownership of data, of content, because it's supposed to be, as in the academia space, not so much rewarding. We have governance processes in place that are also partially in place. And last but not least, I think we really have a range issue. So if we talk about this topic, I would say only very few people really understand what we are talking about. So we have to get a little bit out of our niche. So on the one hand, I think we have a clear objective need to bring this stuff into the organizations, but on the other hand, we still have a poor level of adoption. And the good news is, and it's really dramatic, the perception really changed. So now even our executives and our CEO says really we have to transform our company into a data-driven company. That's really said by our upper management. We consider data more and more as a corporate asset that we have to work with to foster and security. Of course, there are some drivers like personalized healthcare, the integration of real-world data, healthcare data, of course, all the translational research aspects that we have, the increasing collaboration with clinical contract research organizations. But, and if you don't have the C dispenses, I think you still have the issue that if we apply standards, there are also competing standards. So we work, for example, for naming indications, we work with MESH, SNOMED, Vedra, the NCI thesaurus, which is related to CDIS. And many of the systems that we have, they just have created their ad hoc terminologies. So someone had some idea and they pulled together some lists. And these are all things that we need to clean up. So what we need is really a terminology integration framework and a terminology service that's going to support the business. And this is something which is really quite challenging because I think you have to do quite a lot when you would like to bring terminologies into all the business processes. So first of all, you have to provide custom-tailored terminologies. This is inverse. But then you also have to maintain and to enhance them. This is an ongoing process. Every day you get the requests, you have to evaluate them, you have to integrate them. Last but not least, you have to support the people to bring this into the business. That's business consulting. So for example, what are the different minimal models that we need, for example, in biobanking for genomic single point of truth. This is about organizing the metadata and the values that they can take, but again, we're also sometimes very deep into technical consulting. So what are the interfaces, how can the systems integrate with us? So it's both from a business perspective and from a technical perspective. And again, I think the key, and this is something which I really also enjoy about Matrix, is that I think we're really moving on with talking about terminology standards, data standards, and to bring this into data creation processes. I think this has been possibly the core of Matrix activities. And last but not least, we will also confirm this, we need a toolbox, technical service layers around our management system. What I think what's also a very nice point about technology management is that you may also want to consider that you can serve multiple purposes. So of course, the primary purpose for technologies is data capture, so people create records that they are using controlled vocabularies. But you can also use them for data curation processes. There are different tools around, so you can load them into data curation tools as well and align here. Text mining, very important. You have a lot of unstructured information, so prepare your terminologies in a way that they're also suited for text mining, for semantic search and semantic search engines. Last but not least, we also have them to some extent in SharePoint, and also some subject matter expert use them for query expansion. So it's really also thinking about these multiple purposes, we use them to a maximum extent. And I think what we would like to achieve with the data standards, and there's also been quite some information about this during this conference, is we would like to ensure data quality. And data quality can be captured with 3 C's. So one is we would like to have complete data. And we have seen yesterday an example from Geo that when you download the data, important metadata elements like ethnicity, gender, and so on are missing. The data that are around have to be correct, so there should be no semantic mistakes in the data. Another interesting point here is granularity, but also redundancy, because you can code, even if you have controlled vocabularies, you can code the same fact across different metadata elements in different ways. And last but not least, coherency. So ideally, for example, this is something we have started to work on at Roche, is in the area of biobanking. We would like to have a shared minimal model that is applied, for example, in all different pathway systems and so on and so forth. Currently, I think what we see is the contrary. So every data repository, also internally, we deal with, they have their own approach to data modeling and they use proprietary terminologies. And this is just something to give you a flavor of the task. I'm not going to spend too much time on it. This is some data that we got from an application. One is about the route of administration, and the other one is about the dosage form. And they are very small code lists, but even if you look at these very small code lists, they're full with errors. So there are things like typos. There are some things are in there 2 or 3 times. Then, for example, you have inhalation is the route of administration. Aerosol gas is the dosage form. Same applies here. I think we have intranasal subcutaneous, which is the route which would belong here. So even such a short list, you can entirely mess it up. And the interesting thing is, we do not have 10 of these lists in the organization. We do not have 100 of these lists in the organization. we have thousands. And we have to get this clean up. And this is where the terminologies really play an important role. I think there's also a very, very strong value generation behind this. You really improve precision and recall, and with this you improve scientific accuracy. You could really demonstrate that if you query some systems and you get 2 or 3% of the available data just because data quality isn't there. So a little bit more formal discussion here with terminologies compared to ontologies. So what we are doing, what we have been doing at Roche is more terminology management. And I think simply the difference is that terminologies really focus more on the lexical aspects. So you define synonym sets. And I think you have weak semantic relationships, like broad and narrow term, that doesn't tell you whether it's a taxonomic relationship, either relationship, or a part-of relationship, or whatsoever. It's just broad and narrow. And of course, we use RDF standards to code this. And an ontology is more an axiomatization using a logical formalism, usually description logics. You know, the language is old. You use A and T box, and of course, always mention reasoning. So you can validate. You can see if there's a model for your T box, for example. You can calculate subsumption or class membership. And one of the things I'm really struggling a lot, and it's a very interesting discussion, is when we work in research on other areas and we apply terminologies to our data, do we need an ontology or do we need just something like an annotation model? So here this is our internal cell line registry, and this is what I would call an annotation model. So in essence you have a cell line, HeLa, so I can show it, and then you have metadata attributes like the species, the tissue of origin, the morphology, and then behind this you have formalized URIs, so these are, but you just annotate it with control values. In contrast, what you would do on ontology is you really would provide logical axioms for all this stuff that you can see here for the same cell line. This is something that we have derived from the Cellosaurus, for example, to bring in more knowledge about this. But I would say, from my experience, I would say in 90-95% of the cases we have this, and the reason is that the domain masters, the spots for cell lines, for biobanking, they don't belong to the ontologists, they belong to the business. And I would argue that maybe 5 to 10 people in our organization would be able to code and to understand this. Going a little bit into CDISC and the relationship to terminologies. So you have heard, as I mentioned before, that CDISC is available as RDF, and you have wonderful definitions here. For example, you have a meta model, which is called meta model schema, and this really defines for a metadata element what type the value domain is. And one, very simply, it's called enumerated value domain, which is nothing else but a code list. So what are the allowed values for a specific value? Like, for example, what are the permitted value for gender or something like this. And if you look into this value domain, then you have these different lists. Here's an example that you can see. And I just would like to draw your attention to one point. In the model, these lists are flagged as whether you can extend them or not. So in essence, if you look into this from a terminology management perspective, there are closed lists that you cannot extend. There are extendable code lists where you can add new elements. And I think there are also a lot of code lists which do not exist. And the two latter, you have to manage them somewhere. And this is where you need a terminology management system. And I think the good news that we see is that I think that from a research perspective, that CDISC is really going more and more and more into the research space. I mean, CENT is preclinical, pharmacogenomics clearly has it, we have used it in research as well, and I think also all the stuff that has been defined by the different therapeutic areas is very relevant to research. But still, there are large areas which are not yet covered by CDISC, and I think this is where a lot of work from Etrix comes into play. So one is really the standard starter package. So I think the primary purpose of the standard starter package is to make recommendations about data standards where CDISC doesn't offer any, and where we need to find alternative things like, for example, for anatomy, I think we look at Uberon or other systems that can really have a guidance. But I think over time, I think also the standards should converge, and ideally one day, a lot of it is really CDISC, at least a strong part of it might be CDISC. We will have standard recommendations or in-place standards for all the scientific or business entity we work with. And I also would say that the Etrix harmonization service is the practical application of the standards, either coming from the standard package or coming from CDIS to the data that we need to curate and to integrate. And I think this is really giving a strong strategy for the next year how we should really apply this stuff. And I think this is again something where we're really hoping that it will be sustained after the project termination of Etrix. And here's just an example from technology management, which also highlights a little bit the issues that we have. So one thing is that we cannot rely that all the input sources are correct. So I've picked some examples here. So one is from MESH, where you see that the Sertoli-Leydig cell tumor is a super concept of Leydig cell tumor and Sertoli cell tumor, which is semantically wrong. So it should be the other way around. To the same point, what I also think is quite surprising, and again, I'm not a medical doctor, but my definition of a cancer is that it's a malignant neoplasm. But the synonym for lung cancer occurs in the subclass of lung carcinoma, and not every, but there are also other lung cancers here. So how does this play together? And last but not least, there is also the use of terminologies. We have some people that use ICD-10 for clinical trials, and then you have concepts like other disorders of kidney and uteri no elsewhere classified, which is perfect in the context of coding for reimbursement, but semantically, it's an entirely fuzzy concept that will change its extension according to the context you apply it in. So having said this, we have this big task to integrate the knowledge from our different systems. I just would like to give you an example how this works from a practical perspective. So we have master data, where we have indications that have an indication code which is local to the master data management system, but basically it's built on MEDRA. There are also some entries here that don't have a MEDRA code. Then we have this clinical trial management system that also uses ICD codes, and then we have, for example, electronic case report forms that we use for tissue data quality assessments that use CDIS and the NCI thesaurus. And now you have to bring all these things together. And how do we do this? And I think this is a paradigmatic model that's applied everywhere, also at, for example, EBIM. So I think at the representation layer, you need a persistent URI. So just a reference source. It can be internal, or you can use an existing one, which is defined by any kind of reference resource. As a reference layer, you have language, all the synonyms, and you have identifiers that are cross-references to other systems. With the data layer, you have your internal systems that you connect and also other ones. And I think the nice thing about this approach is that you don't move data around, you link them semantically. You're just pointing to them and allowing for transformations. So you can, for example, ask what are all the synonyms for the acronym NCCLS, or I have a mesh identifier with the corresponding meta code, knowing it's not the one-to-one mapping. And this is how we materialize this in our technology management system. This is a screenshot here. So on top, I have picked here the example of acute myeloid leukemia. It has a preferred term, it has a definition, it has a set of synonyms where we also maintain the provenance, and then here you have all the different cross-references. And this is how we semantically glue together all our internal applications. So the task that we have foreseen in a data standards workstream for the next 2 years at Roche is that we would like to connect the master data management system, which is extremely important and very frequently also neglected in our discussions, because if you go to PE, to PT and beyond, this is where the spots, the civic points of truth are. Then the metadata registry, which is very close to what you have defined in the data model schema plus the implementation guidelines, and the terminology management system. I also would like to make a bit of advertising here. I think what's also, we have a Destroyer Alliance project going on, which is going to go to the third phase, and we're going to set up a terminology ontology mapping service together with the Emerald EBI. So if you're interested to join, also possibly if you're a member of the Destroyer Alliance to be a funding contributor, please contact me. But again, we have seen that the integration of these resources like Vendra, Snowbit, and many others is really crucial to do the semantic connection of our internal repositories for data sharing. So I think the integration of standardized terminologies is something which is ubiquitous. And by doing so, we really lower the thresholds for adoption integration of data. But what you have to do is you have to support the business with integration tasks at all levels. So really reaching out actively and helping the people to get the data aligned with the standard. Very important is you have to bring the knowledge to the point of usage, so seamless integration using technical interfaces. The most important part is communication. You have to communicate. It's everything else but self-explanatory. We have to support software vendors. Many software vendors have closed systems that are not able to read in terminologies and ontologies. Last but not least, also content providers like Clarivate, Analytics, and some others. There would also be a need for doing a kind of alignment. And I think the most important one, and this is a very, very good byproduct of the activities, you really create and foster semantic awareness. People really start to understand what semantics are and how we can create value with semantics. Finally, I would like to acknowledge my colleagues from the Romacker 3 plus the team I belong to at Roche. Thank you very much.
Just wondering with the IDMP terminologies and mapping those into CDIS, have you done it that way around, or did you just import most of the IDMP terminologies and then it's something you've got to do still? Because it's a project we're embarking on, so I just kind of wonder, there's a lot of people that want to help with us that are already ahead of the curve and many behind the curve.
Yeah, I think this is a very, actually it's an excellent question, interesting question, because the IDMP shares a lot of commonalities, as you pointed out yesterday, with CDIS. And from a processing perspective, the IDMP vocabularies, they go into the master data management system. But for them, for example, things like terminology management, cross-references are out of scope. So we are currently exactly looking into this. And so it will be around the landscape that you have seen. So we will do the mapping between the classical master data management and terminology management system and register the identifier or the metadata elements in the GUS now. I think this is really a complete set of capabilities that you need. So very important topic, and we are working on it.
I was wondering about something you said, that ontologies can help to improve quality of data curation. So we recently had a brainstorm internally where we thought about, can we use machine learning to make the data curation process go faster? And quickly figured out that the solution space is so huge that even though potentially maybe you could do it, in practice it will become very hard to get the right sample of the solution space. If you look at other companies like Tamer are doing, they're using conversational AI. But I was wondering, did you think about how ontologies or terminologies could be used in machine learning? It's just a question.
I think there are two aspects. I think you can certainly use machine learning, for example, to identify candidates that you may want to put into our terminologies. From my experience, machine learning for a curation task, this is maybe a strong position I'm taking, is more or less useless. Because when I read in, for example, some data along with the vocabularies, then I can do some matching. And if there's an element which doesn't fit, I have to look at it anyway. So and then usually with string-based algorithms, you're more or less the same level of accuracy. So like doing normalization of strings, also some kind of Liebenstein word distance. And then you have to look at it anyway. So I wouldn't see, for an experienced data curator, I wouldn't see any advantage. In the difficult cases that you have, for example, this is also where machine learning doesn't work. So for example, let's say you have cystic fibrosis in your terminology, and all of a sudden mucoviscidosis pops up. That's even a machine learning algorithm. This is also something that people from Tabor confirmed to me. I was asking, they wouldn't detect it. So at this level, I'm really a little bit skeptical, I would say.